looking at yesterday. And so, oh, the other thing, the sheet of clues, nobody mentioned to me or nobody sent me a message that you didn't have the worksheet right away. I got a call from Miss Armendariz, who I have second hour, and she said you can't read it on the video, and I was intending on posting the worksheet. And so, if you guys are missing something, I just forgot to post it after I had linked the other videos and so forth. So make certain somebody just send me a message. You can do it on the classroom or an email and just say, hey, I need the physical, or I guess the digital copy of the building and periodic tables. I can't see it. So anyway, let's go over this. Looking at this, we started out yesterday. I think I answered like the first four with you. I'll go over it real quick. Clue one was just telling you which group these elements belonged in, which vertical column, or excuse me, which elements were in the same group. Clue two said H has 4 valence electrons, and so we know group 14 has 4 valence electrons. These have 1, these have 2, 3, 4, 5, 6, 7, 8. Okay, so it goes along like that. Because H has 4 valence, we know that it's one of these. We don't know which one, but it's one of those 3. And notice IP and H all go together in the same group or family because of clue 1. So we know H, I, and P are going to go here. We don't know in which order. Clue 3 said PC2 is a formula for an oxide. We haven't done naming yet. So that's going to, I kind of had to tell you that C is oxygen. And so if I look at my periodic table, oxygen lives in group 16, period 2. So 16.2, this is C is oxygen, so this is going to be C. That also tells me that M and S are here. So it's either going to be CMS or CSM. I can't tell right now, but I do have that kind of clue going for me. Okay, by the time we got to clue 4, that was the last one we did together. It said G is a noble gas. We know noble gases are right here in group 18. And so looking at clue 1, it says D, G, L, Z are in the same family. So D, G, L, and Z. We don't know which order they go in, but we know they are in that column. So this is where I started having you guys do this. Clue 5 says U is an alkali metal. Well, you had to know alkali metals are group 1, so it's going to be somewhere down this column. And if you look at what U goes with, U, K, W, and R are all in the same group. Not only that, that was the only other one that had 4, since we knew 4, these DGLZ went here. That kind of limited where U, K, W, and R went. Clue 6 says E has 5 electrons in its outer shell. Well, that would be 5 valence electrons. That's going to be in group 15. And so E goes with A and O. So I'm going to say A, E, and O. I'll go in this column. Let's see. Next clue says N is an alkaline earth metal. Well, you had to recall alkaline earth metals are group 2. Okay, that's the name of that group. So J, N, and V go together in that group. We're now down to clue 8, which says T has an electron dot diagram. Now, this isn't exactly how we do it. I just did it because of just space in this fashion. Normally when we drew this, we would start right, top, left, okay, then bottom, and then pair them up. But you'll notice just for space and how I had to do it, it's just inverted. So I went like this instead. But still, you should be able to tell, hey, that's 3 valence electrons. That's got to be group 13. And so let's see, BFT go together. Okay. By default, there's only one group left and there's only one set of elements. Clue number 9 says Q is a halogen. Well, fortunately, group 17 are known as the halogens. Okay. So we know Q, X, and Y go here. So for the first 9 clues, it kind of tells us which column the elements belong to. The only one we know for sure is oxygen at this point. The rest of the clues, 10 through 28, are going to help us organize where these elements go within their respective groups. So clue 10 says F has the smallest mass in its family. Well, if you look at your periodic table, mass increases as you go down. So if it has the smallest, F must be at the top. Clue 11 says T has a radius that is larger than B. Well, you have to recall your periodic trends. As you go down, the radius gets bigger. So if T is bigger, that means T is at the bottom and B goes here. So we're done with that group 13. Clue 12 said N is smaller than V, which is smaller than J, which is smaller than K. So at first this is kind of confusing because you're like, well, it's mentioning these three, but then it mentions one from a different group. Why is that? Why is it putting, a group of three together and then one odd element? Well, let's look at that clue and just ignore the K part. So it says N is smaller than V, V is smaller than J. So out of those three, which one would be the smallest? It would be N. Okay, so N is going to go there. So N is the smallest. And then which one's the biggest? So N is smaller than V, V is smaller than J. That means J is the biggest out of those three, which means this has to be V. V is the middle one, NVJ. Now that last part of the clue, it says J is smaller than K. Well, at first you're like, that's kind of confusing, but once you look at it and you figure out where J belongs, there's only one place where K could go. Okay, K cannot be this one, or this one, because if J is smaller than K, element J has 4 energy levels. Oops, excuse me, 4 rings, right? Because of the period number 4 over here. So if you put K here, it would only have 1 ring. If you put it here, it would have 2 rings. If you put it here, it would have 3 rings. 1, 2, or 3 rings are always going to be smaller than something having 4 rings or 4 shells. If you put K here, yeah, need my pen. If you put K here, you recall as you go across a period, atoms get smaller because you have more protons pulling on those valence electrons. So this is the only place K would be that would make J smaller than K. So that clue, even though like the first part kind of made sense, but then that K part might have been confusing, it actually kind of told you where K belongs. Okay, number 13, it says P has the largest radius in its family. Well, that tells me that, once again, it's got to go at the bottom because they get bigger as you go down. I is a metalloid that is used in computer chips. So even if you don't know what things are used in computer chips, if you look at this is where that stair step should be, right? The one that separates the metals, nonmetals, and metalloids. Well, it says that I is a metalloid. You guys recall that metalloids are things that touch that stair step. Element here is not a metalloid because it's, granted, I mean, it's touching at a point, but it can't be touching at a point. It's got to be touching with a side. This has to be I because this is a metalloid. And if you look at it, 14, group 14, period 3 on your periodic table, 14.3, you'll notice it's silicon. And you've probably heard, that computer chips are made of silicon, or you've heard of like Silicon Valley, out in California where they do all the tech stuff, all the computer stuff. So even if you didn't know, what elements used in computer chips, the rest of the clue actually gave you enough information to solve where I should go. H, therefore, is going to be the last element in that group. Okay, let's look at 15. It says S's radius is greater than that of C. Well, that clue doesn't tell us a lot because if you look at this, either one of those would actually be true in this case. For clue 17, this one's probably going to be fairly tricky because it says Y is a liquid where Q is a gas at room temperature. The only way that you would know their state of matter is you would have to look at a different periodic table that has some information on states of matter. In the classroom, we've got one that's color-coded. Everything that's a solid is going to be black. Everything that's a liquid is blue, and everything that is a gas is red. In one of the previous lectures, I did tell you the only two liquid elements at room temperature. Let me see here if I can find the, maybe ptable.com has a copy. I'm going to try to look and see if it has a one with states of matter. Otherwise, you're just going to kind of have to remember, I guess. Oh, here's one. Okay. Share screen. Share this guy. Okay. So I don't know if you guys can see this. You should be able to see it. So this is ptable.com, and what it usually comes up with is this one. Okay, but if you click this tab next to it, it says properties. It is color coded. And so you will notice that anything in here that is black, anything that's listed in there in black is going to be a solid at room temperature. So you'll notice most of the elements are solid. There are two that are printed in blue. That means they're liquid at room temperature, mercury and bromine. And then all these that are in red are gases. Okay. Now you may say, what about these gray ones? These gray ones are synthetic. That means they're not found in nature. Okay. And in fact, most of those elements don't even exist. Okay. Scientists created those elements in a basically what's called a particle accelerator, where they smashed small atoms together and fused them into larger elements. As they do that, there's a reason why they're not found in nature. It's because they're really unstable, and so they tend to fall apart. And so we'll never really mention any of these down here at the bottom, all these synthetic ones, because they're really, I don't know, they're not super important to us because, one, you're never going to see them because they really don't exist. Yeah, scientists created, a few hundred atoms of them, but you also have to understand that they fall apart as soon as they're formed. So not super important to stuff that we're doing. All right, so anyway, with this knowledge, you should be able to answer that question then. So if you ever are asked a question about state of matter, if they're a solid, liquid, or gas, just go to ptable.com and then click this properties tab, the second one, and that'll bring you the different the different states. Okay, so back to our building activity. Okay, so that was going to be clue number 17 says why is a liquid. And so, like we said, mercury is one of the liquids, bromine's the other. Mercury is not going to be on this table because we don't have group 12. So bromine is in group 17, period 4. We do have 17.4. 17.4 happens to be here. It says Y is a liquid. There's your Y. And then it says Q is a gas. Well, guess what? Both of these were gases. If you go back and look at the table, both fluorine and chlorine are gases, so can't really tell yet. Clue 18 says X has a radius smaller than Q. Well, if X is smaller, that means it's on the top. So XQ and then Y. Clue 19 says D has 10 protons. Well, you know that has an atomic number of 10, which is neon, which is group 18, period 2. So we know this guy has to be D. R is the least reactive in its group. Positive ions of U are considered to be dangerous to those with heart disease and should be avoided in their diet in large quantities. So this one, least reactive. Okay, I'm going to give you guys kind of a hint here. I'm going to show you a real brief video here on reactivity of alkali metals. It's probably not going to have sound, but I will kind of narrate it so you can tell what's going on here. I'm going to do that, and I'm going to go down here. I need to come back, and I need to go here, and I'm going to hit share. Okay, so here we can see YouTube. And what do we got? I'm going to say reactivity of alkali metals. So that's that first group here. And so I don't think you'll be able to hear it, but I will kind of narrate it. Okay, so anyway, they're talking about these alkali metals. So these are all elements there in the first column. This one happens to be lithium. Okay, so you'll notice there he has a chunk of lithium. He took like an X-Acto knife and he sliced it. This is in real time. This is taking about 10 seconds. So you'll notice when he cut it, it was real shiny, real lustrous. And you'll notice here that in that span of that short amount of time, it's already corroded. It's oxidized already. It's turned dark like the other section there. He scraped it with a knife. He's showing that, so there's another sample of lithium. They store it under oil because it's so reactive. It reacts with air. Here he's going to cut it again. Oh, this is sodium, I think, in this example. So there he cut this sample of sodium. Notice corrodes very quickly. Here's potassium, and it corrodes even more quickly. So you're noticing that, yeah, they all react with air, and as you go down, it's happening much more rapidly. Okay, now he's going to show the reactivity of these with water. He's going to take a chunk of lithium here and stick it into some water. You're going to notice that it's bubbling and fizzing. Okay, it's visibly reacting with the water. Okay, what it's doing is that it's releasing hydrogen gas. Here's a sample of sodium. Once again, it is also kind of bubbling and fizzing and dancing around the surface of the water. As it releases that hydrogen gas, what it's making is then sodium hydroxide. You don't need to know that, but it is reacting. Okay. Now, the next one he's going to do here is potassium. So as he puts a little chunk of potassium in the water, you notice it catches fire. Okay. So once again, hydrogen, one of the properties of hydrogen is flammable, but it releases enough energy that it actually catches on fire. Okay. So here's rubidium. Notice rubidium, it reacts much more quickly. The instant it hits the water, it explodes. And then he's going to do cesium here in just a second. So this next one is cesium. Puts it in there, the beaker blows apart instantly. Okay. So they all have very similar, but yet not identical properties. And you may have noticed that the reactivity as you go down a group, it becomes more reactive. Okay, so let's see. It says, what do we say? We said that R is the least reactive in its group, and so you might be tempted to put R at the very top, but I'm going to caution you against this. R is not going to go at the top because R is not going to go up here in group 1, period 1, because that's where hydrogen lives. Hydrogen is not an alkali metal. Okay, hydrogen is not an alkali metal. I've mentioned this in past lessons that hydrogen is kind of an odd element. They stick it over there because it has one valence electron, just like those other elements, but it's really kind of unique or different than other things. So anyway, hydrogen is not an alkali metal, so that means R must go here. Okay, and so that would be the least reactive of the alkali metals. And then it said positive ions of U are dangerous to those with heart disease. Well, let's skip that just for a second, because if you look at the next clue, 21, it said W is a gas. Well, in that first column, there's only one gas, which is hydrogen. And once again, you'd have to have a little background information like that, ptable.com, where you looked at states of matter. And so that leaves only one space for U, which is here. And now looking at the clue, it said positive ions of U are considered dangerous to those with heart disease, and you need to avoid it in your diet. Well, if you look at that, that's going to be group 1, period 3, which is sodium. And you have heard of people that have sodium restrictions in their diets where they have to have low sodium things. So, yeah, there is that clue. 22 says atom Z has 2 neutrons. There's only one element that has 2 neutrons. It's helium, because you look at atomic number 2, mass of 4. That means it has 2 protons, 2 neutrons. So that's Z. It says electrons of atom E are distributed over 2 energy levels. Well, that would have to be this one, because remember, this is 2 energy levels because it's in the second period. Okay, don't think that as 1, because if it had 1, it'd be up here. So only hydrogen and helium only have 1. Everything else has at least 2. So E fits here. L has the highest mass in its family. That tells me that L needs to be at the bottom. Okay. Not only that, but now we're missing G. So G goes here. So Z, D, G, and L. H is the least metallic element in its group. Well, yeah, that makes sense because it's a nonmetal. So we already knew this. These are both metalloids, which have some properties of metals. So that makes sense. 26 atoms or electrons of atom O are distributed over 3 energy levels. That would mean O goes here, which means this has to be A. And let's see, A is more metallic than either O or E, and it would be because this would be a metalloid. Oh, I skipped one clue, sorry. Let's go up to clue 16. It said C is more closely related to S than M. Okay, well, if C is more closely related to S than M, that means it's going to be closer to it on the table. So just like when we looked at the reactivities, you know, lithium was more closely related to sodium than it was potassium, cesium, you know, or any of those other elements, rubidium. Okay, so the closer elements are on the periodic table, the more in common or more similar their properties are going to be. They're all going to be similar, not identical. And like I said, the closer they are physically on the table, the closer their properties are going to be. So that's how you would have to do this building a periodic table activity. Okay.